We can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends. Our affinity with sci-fi movies and perhaps the Bible would point toward a big bad apocalypse, but what if we told you that the end of the universe is no different than its inception? The James Webb Telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago. In doing so, he gave us the most realistic starting point to imagine the end of the world. We can look to light that began its journey before there were galaxies, and that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for those who don't believe in the Big Bang. The answer is, well, you can see it. We're heading towards Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. If we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epic of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today, mainly because the astronomical community has now readily accepted that our history in this universe starts with the Big Bang, and the ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common word in the theoretical knowledge of astronomy and space, we're hardly aware of the what's and the hows of the phenomenon, unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense, that inflated to extreme lengths. All of this happened when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of negative 34 seconds old, that is 100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or inflation. During this process, space expanded faster than the speed of light. So yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously, from subatomic sized to golf ball sized. 1 second after the inflation, the universe began to cool, which led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second, our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long, long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang based only on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuits to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from the expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproved as well. Yes, we're pretty sure about the Big Bang as a concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you pick some science textbooks from the early 90s, you'd read about how the universe is widening. In other words, the universe is expanding, and that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails, and more importantly, we got to ask ourselves if the universe is actually expanding. Because, spoiler alert, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. And hey, while the world is still intact, you might want to improve your internet experience, safe and secure, because we certainly have. This is why we're happy to reveal our very own secret to secure browsing and accessing deep blocked content to make some hefty, informative videos. Today's video is sponsored by the champion of safe and accessible internet, Atlas VPN, with more than 6 million users worldwide. Atlas is changing the game for everyone. Alright, this service won't be available in space, but Atlas would make your internet experience super secure and quick. Can't watch shows that are locked in your region? Connect Atlas within a microsecond, voila, you're in. You don't have to be an expert in tech or computers to work this service, it works like a charm for anyone and everyone, that too for just $1.83 per month plus 3 months extra. So why choose Atlas? Atlas kills malware attacks, keeps your good searches secure, unlocks content from all over the world, and offers the best deals in the market. You can get all of this for all of your devices via a single subscription. Grab the big deal because now Atlas VPN Premium is just $1.83 per month plus 3 months extra, and with a 30-day money-back guarantee. Protect your privacy and get many benefits of Atlas VPN for a ridiculously low price. You can take this deal by clicking the link in the video description below. Be quick, as it's a limited time offer. So while we thank Atlas VPN for sponsoring this video, click the link in the description to avail yourself of the limited time offer. Your internet experience just got a whole lot better. Now, before jumping into the implications of this groundbreaking shift in our universe's trajectory, let's just talk about our understanding of this perplexing phenomenon in the first place. The most common knowledge associated with the Big Bang characterizes it as an explosion. And well, fiction and popular media have put solid imagery to this process as well. Any piece of media would depict the inception of the universe as some sort of blast that hung tons of energy and matter, spreading in every direction. Scientifically speaking, that sort of visualization isn't correct. Despite the widespread use of the word explosion or inflation, the birth of the universe wasn't exactly a blast, and scientists want us to correct our understanding of the universe. In NASA's own words, the universe did not expand into space, as space did not exist before the universe. Instead, it is better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe lived through a durable cosmic period that was only disrupted by the reionization in space. Before that particular chemical conjecture, our universe was just pitch black dark. The "let there be light" moment of the universe only occurred 400 million years after the Big Bang. Yes, that's right. You see, the big explosion only created the basic tenet of all living beings and heavenly bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple, there were no stars or galaxies. When that was rectified, as clumps of gas turned into stars and galaxies, only then did the universe get out of its cosmic dark ages. So, here's a little trivia for you. When do you think our solar system came into being, if the universe was just darkness and eeriness for 400 million years? Well, our solar system was born 9 billion years after the Big Bang. So, sorry, sci-fi movies, there's a huge disconnect between the so-called explosion and scientific theory. And, of course, this changes everything. The way things are, our universe still exists as a single inception point. It hasn't moved or expanded ever since the Big Bang. What really happens is that space has been stretching a long time, and it carries matter with its trajectory. To put it in clear-cut words, the universe isn't expanding the way we visualize it or even understand it. It is actually the active stretching of space that precedes the expansion of the universe. We know it's a bit complicated to comprehend this, but it's also important to understand the implications of what we're about to tell you. For the purpose of this video, we'd continue to use the phrase, expansion of the universe, to signify the active movement of our space, but it's important to remember that it's hardly an expansion to begin with. Alright, now that we've addressed the scope of expansion, let's talk about this particular event. Prior to 1998, scientists had this preconceived notion that the universe was expanding, but in a limited capacity. Of course, the scientific theory here predicted that as time progressed, this expansion would decelerate due to gravity pulling all of the matter inward. Gravity, after all, exists beyond our world. You see, just because we experience it on Earth doesn't mean gravity doesn't exist in the universe as well. So yes, the expansion of the universe should slow down. But then, in 1998, an observation came along that made everyone rethink their calculations. By studying the brightness of Type 1a supernovae, remember this, as it's very important for our observation, scientists observed that these supernovae were dimmer than expected. The brightness of an object tells you how far it is away from you. Therefore, scientists concluded that these stars were farther than what had been predicted. This caused a shift in our knowledge of space and universe expansion. If you've made it this far into the video, you clearly share our passion for exploring the mysteries of the universe and uncovering the truths behind these groundbreaking discoveries. We dive deep into these topics regularly, bringing you the latest updates from space science, astronomy, and beyond. If that's something you're excited about too, make sure to hit that subscribe button and turn on notifications, so you never miss out on our upcoming videos. We've got so much more to explore together, and your support helps us keep bringing you content that makes the wonders of the universe more accessible. Don't forget to like this video and share it with fellow space enthusiasts. Thanks for watching, and we'll see you in the next one.